Assalamualaikum warahmatullahi wabarakatuh. My name is Ainur Yushazmie binti Azaha, and today I would like to present mechanical properties of Pla-Polygonum minus Biocomposite and its multifunctional properties. So, Polygonum minus is a scientific name for Vietnam coriander, or we can call it Kesum in Malay. So, I did some research background. So, Malaysia has its title. Malaysia is being called a dump country, which because Malaysia is the world most importer of the plastic waste. As you can see, the pie chart besides, the developed countries such as US and Japan contribute a lot of plastic waste to Malaysia. And the second one is imported waste being dumped in the landfill or burned in an open air. I think it is not a good solution because whenever waste is being dumped in the landfill, it will produce leachate, which means it will contribute another pollution or another problem in the future. And if we burn in an open air, we burn waste in an open air, it will release a harmful toxic or harmful gases. And the last one is Malaysia does not have an adequate system to deal with the surge plastic waste import. Okay, next. Problem statement. Okay. The first problem statement is low recycling rate. So Malaysia does not have Malaysia only can recycle a few types of plastic such as PP, polypropylene and polyethylene PE. Second, the next one is the cost of the current alternative plastic is quite costly for me. It is because whenever we go to the supermarket, we have to pay around 20 cents per pieces. And next, the tensile strength of the current alternative packaging. So this problem statement, it is focused more on paper bag or paper packaging, as we know that paper packaging we cannot put more item in it. So whenever it is overloaded, it will rip off. And the last one is biodegradability. So as we know that the plastic took 100 years to fully degrade, and sometimes it brings harm to the environment. So why we need to solve? Because we want to follow SDG 12, which is the sustainable consumptions and production pattern, in more eco-friendly style. So this is the alternative solution that I want to propose, which is the PLA Kesum Biocomposite. So PLA being reinforced with the Kesum fiber to produce PLA Kesum Biocomposite. Okay, why I choose Kesum? It is because Kesum in Malaysia is abundant, and also I want to expand the applications of the use of the Kesum. So instead of we just using it in cooking, why don't we expand it? We use it in engineering or packaging or medical. So the figure below shows that the final product of the PLA Kesum Biocomposite. So the literature review. So Kesum can be antimicrobial agent as it contains high antioxidant and also high antimicrobial activity. High antioxidant means it can fight cancer, and high antimicrobial activity, which means that it can prolong the shelf life of the product. So for the PLA part, PLA is a biopolymer that came from the cornstarch. Okay, biopolymer has some benefit and it shows great performance of biodegradability, processability and compostability. So objective. The first objective is to produce a biocomposite thin film of PLA Kesum via solver casting method and observe the interactions of fiber and matrix by fracture morphology using SEM. Second one is to assess the effect of Kesum fiber content and size on tensile strength of the biocomposite. And the last one is to investigate the other characteristic or other properties such as wettability and transparency of PLA Kesum biocomposite. So for the flowchart to prepare biocomposite, so the PLA Kesum can be purchased at the market. Mold, chloroform, and magnetic stirrer was prepared. So next, the PLA and Kesum fiber underwent drying, grinding, and sieving process. No. The PLA is being cleaned with the tissue, clean tissue in order to remove impurity, and Kesum was underwent a drying, grinding, and sieving process. Okay. Next, PLA Kesum biocomposite is prepared using solution casting method. Next, after the PLA Kesum biocomposite is produced, several testing was conducted, such as tensile, contact angle, UV vis analysis, and UV vis analysis. Okay, next, the biocomposite and fiber was morphology was observed using SEM, and the obtained data was analyzed. Okay, tensile test. So the graph below shows the tensile strength of the PLA Kesum biocomposite with different content of fiber and different length of Kesum fiber. So as you can see, the grey one, it shows that 250 micron in size. It is an optimum fiber length as it's recorded the highest strength. And also for the content of fiber, 3 weight percent is an optimum weight percent for the biocomposite in order to achieve higher tensile strength. Okay, this is the interesting part, the SN micrograph of the Kesum fiber. So Kesum fiber have some special characteristic, which is it has the spiral type of fiber. So I did some reading as I cannot identify what is the spiral types of fiber, and it shows that entanglement of the fiber, it shows that it is a herbarium plant species, so it's mean that Kesum have spiral type fiber, has spiral fiber. It shows that Kesum is a herb. Okay, next, the SAM micrograph of the composite. So as you can see, in A, it is the fracture propagate, crack propagate during tensile test of PLA that leads to fracture to happen as there is no grip. There is no grip that can delay the time for fracture to happen. Okay, for B, the PLA Kesum biocomposite. As you can see, the fiber pull out. So the fiber pull out, it is due to the fracture flat fiber during tensile test is performed. Also, the fracture also happen because of the presence of void in the fiber itself. So for contact angle, as you can see in A and B. So for A is contact angle for PLA and B is contact angle for PLA Kesum biocomposite. Okay. For PLA, it is recorded 74.12 degrees of contact angle. While for PLA Kesum biocomposite, it is recorded 73.05 degrees of contact angle. Okay. As you heard, that both of these samples have contact angle below than 90 degrees. It means that both shows a good wettability properties. Okay. Good wettability properties means it is hydrophilic, which means it attracts more on water. However, in order to compare, PLA is more hydrophobic compared to PLA Kesum Biocomposite because of the slightly difference in contact angle decrease that being recorded. Okay, next, the UV vis analysis. Okay, the wavelength of the visible light is around 380 nanometers to 700 nanometers. Okay, so I have did some reading as for PLA. So this graph shows that this graph is for UV vis analysis for PLA Kesum Biocomposite. So I did some reading for PLA. It is stated that the percentage of the transmitters for PLA is also high. It is around 400 nanometer to 700 nanometers. Okay, but for PLA Kesum Biocomposite, it shows that in the figure, in the graph, it shows that there is not much changes for Biocomposite, as it also recorded around 380 nanometers to 800 nanometers. 340 nanometers to 800 nanometers. Okay, which means it also have good transparency properties. Okay, good transparency means that it has good dispersions of fiber in PLA matrix, which means the Kesum fiber is dispersed equally in the PLA matrix. Okay, to conclude, 250 micron and 3% showed an optimal size and weight percent in order to achieve high tensile strength. Next, the micrograph of the fracture morphology of PLA and PLA Kesum Biocomposite. It shows the propagations of crack for PLA and strong grip of the fiber towards the matrix of PLA Kesum Biocomposite. And the last one is the PLA Kesum Biocomposite has good wettability properties as its contact angle is below the 90 degrees, and it also have good transparency, so it is acceptable for us to it is acceptable for food packaging, for if we want to make it food packaging. So recommendation for future study is to investigate the time consumed and weight loss of the biocomposite to fully degrade in different temperature, in different environment, in different humidity. And the next one is the additions of plasticizer in order to increase the flexibility of the biocomposite. And the last one is to study more on microbiome properties of the biocomposite, not only for the food applications, but also in medical or other applications. So that's all for me. Thank you.